Hello, and welcome to this ethical dilemma in science, where we are going to take a look at carbon offsets and ask the question, are we reducing atmospheric carbon elsewhere, or are we possibly passing the buck? Before we get started with the topic here today, I wanted to begin with a public service announcement, and so I'm not going to do the annoying kind of whine that goes along with it, but go into, again, a PSA for here. So, we're, coming out of the winter, going into the spring, hopefully going into the summer soon, hopefully. Big issue out there. We got dogs that are being left in cars. The windows, even the windows are cracked a little bit. The cars heat up really, really fast. And because of that, it's dangerous for the dogs to be left in a car alone for really in any period of time. If we look at the data over here, and this is from Tufts University Veterinary Medical Center, it basically shows you that kind of inside a closed car, it is very rapidly going to increase in temperature over a period of time, even though the outside temperature is going to stay relatively the same. And it's estimated that within a relatively short period of time, the temperature inside of a car with the windows up or even with the windows cracked a little bit could end up 15, 20, 25 degrees warmer than it is outside. And so if it's already uncomfortably warm outside, it is going to be unbearable and potentially life-threatening for animals if they're left in a car. And so I want you to really consider that and keep that in mind. Let's keep our pets safely, keep the dogs outside of being kept in hot cars. So now back to our regularly scheduled programming. And so what is it that we're going to be talking about? We're introduced this topic as carbon offsets, this idea that many individuals, many corporations are interested in reducing, in essence, their carbon dioxide impact on the environment. And the way that many people are doing this is in an effort to either reduce their own emissions, so kind of minimize what they're burning in terms of fossil fuel, so minimize trips if they're going out, stop at a few places as opposed to running out to a different location each time. But there may be a limit to what an individual or even a small company is able to do to reduce their carbon dioxide emissions. And so, again, I'm recording this in the second week of April 2022, just some articles that have come out within the last 2 or 3 weeks where we've seen the Red Sox baseball team started the Major League Baseball over the past weekend. They're making an effort to go carbon neutral. We've got, I think this is a news press release for an organization in Canada that has developed a way to do carbon neutral direct mailing. So all of the things that you get in your mailbox that are just kind of showing up randomly and potentially a large pollution impact associated with it. And then again, earlier today, taking a look at CNN, Mattel releasing the first set of carbon neutral toys, including a carbon neutral Matchbox Tesla, as well as the little building blocks and things like that they've got available. And so we're seeing that this is a big issue. We're seeing a lot of companies that are interested in reducing their carbon impact, their fossil fuel impact, or their greenhouse gas impact. So, what is it that everybody's talking about? What is the concern about carbon dioxide in the environment? And what's going on and what can be done? And so if we take a look at it, what we've got basically is going to be an atmosphere kind of over the surface of the planet. So in this photo from kind of the NASA gallery of images, you can see the planet, maybe not see the surface of the planet, but you can see some nice clouds kind of going through here. And then we've got higher areas of the atmosphere kind of above the cloud, up to the point where, we may start to see, satellites, or we may see, the International Space Station kind of going through there before we kind of leave the atmosphere and get out into, kind of real outer space. But we've got the presence of this atmosphere that really allows for life to occur on our planet. And so if we take a look at the composition of the materials that are found within our atmosphere, we can see that the predominant component is going to be nitrogen, estimated at about 78% of the air that we breathe is nitrogen. A smaller percentage of oxygen, but oxygen, essential for us in order to be able to survive. We need to, have a ready supply of oxygen to breathe. That's about 21%, 20.95. So the combination of those two, 78% for nitrogen, about 21% for oxygen, is going to get us to 99%. But there's still going to be a few other things as well. There's going to be a noble gas, argon, and then we finally get down to carbon dioxide. Carbon dioxide estimated at about 0.038%. So a very, very small component within our atmosphere, but it has major effects on the characteristics of the atmosphere. Also, kind of in here in yellow, kind of in the slide, kind of represented up here on the graph, are a whole variety of other things like water vapor, methane gases, hydrogen, ozone, which again has a protective effect, are at really, really low levels within the atmosphere. And yet, the presence of these components within our atmosphere are incredibly important for the kind of survivability of this planet, the ability to have life on our planet as we see it kind of going on and outside. And so some of those characteristics, so we can see the atmosphere here, again, in that image. So we can see the ground here, the atmosphere, different layers of the atmosphere that are going to be present. One of those components, we said, was going to be ozone. It's going to be present within the stratospheric zone, kind of a region within our atmosphere. But it is going to be incredibly important because there's ultraviolet radiation, ultraviolet energy that is going to be coming from the sun. And ultraviolet B and ultraviolet C are going to be kind of greatly reduced by the presence of ozone within our atmosphere. And the most harmful of these varieties, UVB and UVC. UVC is blocked completely by our ozone layer. UVB is kind of reduced to a very great extent as it's passing through the ozone layer. And maybe a little bit of reduction of UVA, but still a lot of UVA, ultraviolet radiation coming down to the surface. So, remember your sunscreen. This is energy that could potentially damage your skin, damage the cells on your skin, damage the DNA. And it would be a whole lot worse if we didn't have that ozone being present within our environment. If we take a look at the characteristics associated with our environment, we can we hear the term greenhouse effect or greenhouse gases. What is that? What does it mean? And so basically on this slide, and again, this one is from the Energy Independence Agency of the government. So we've got the globe here kind of representing the Earth. We've got the lighter blue region kind of going off from the surface, kind of heading out towards outer space. And then we've got that boundary. So we've got the atmosphere that's going to be present. Sunlight is going to be kind of illuminating our planet, as we've talked previously in some of these lectures, some of these talks. That sunlight is going to be coming down. It's going to penetrate through the atmosphere. Portions of it are going to bounce off. Some of it's not going to make it all the way down to the surface of the Earth. But there's going to be a portion of it that is going to make it down. A portion of that sunlight energy. And if you've gone out in the summer in bare feet and walked on a blacktop, a pavement, asphalt, any of that, that surface is really going to absorb the sunlight. It's going to absorb that energy, and it's going to get really hot. And that's what happens on the surface of our planet. The sunlight is going to heat up our surface of our planet. That is going to kind of radiate back into the air, and in doing so, that's going to heat our atmosphere. Now, some of the same characteristics that allow for things to kind of pass through, but other things to bounce off, some of that heat that is produced by the solar heating of our surface, the sunlight hitting the surface on our planet, is going to go up in the atmosphere, but then it's going to be trapped within the atmosphere. Things like carbon dioxide and methane within our atmosphere, examples of the greenhouse gases, are going to be very good at trapping the heat temperature onto the surface of the planet. And that's incredibly important for us to be able to survive on the planet. But again, keep in mind, go back to the previous slide for a second, that we've got natural greenhouse effect. The presence of our atmosphere makes our planet like a greenhouse that kind of stabilizes the temperature and gives us a livable temperature range so that we can survive. And so again, an example of a real greenhouse, or at least a greenhouse that we can see and kind of visualize. I got this off of a web page looking at winter greenhouse tips. And so you've got a greenhouse here, you've got a snowy area around the outside. But within this greenhouse are going to be a lot of plants. It looks like potentially a few tomato plants, and see the little reddish tomatoes kind of appearing there, and other things that are growing in there. And so in this situation, this winter greenhouse is this enclosed environment, kind of similar to what we've got with our atmosphere as an enclosed environment. Sunlight is able to come through. We're able to keep the heat within the greenhouse so that our nice little tomato plants here don't get frostbit. They don't get, they don't get killed. We're able to grow things throughout the winter using a greenhouse like that. And in the same way, we can have life on our planet because the greenhouse gases, the natural gases within our environment, are going to allow for a temperature range that is suitable for our lives. And so if we take a look at this, we can see there's the Philadelphia forecast from earlier in the week. Actually, I think this was last week. And you can see, we've got a period of highs. So, this week was going to be 75, 80, 83, or 82, 83. But then we take a look at it, and the nighttime temperatures, it's going to be a little bit cooler. And so we think about that, and it's like, okay, well, when the sun's out, it's going to be daytime, and sunlight's going to hit the surface of the ground, and it's going to heat the ground. At night, the sun's on the other side of the planet. Actually, the planet is rotated, and so we, at nighttime are facing away from the sun. So we don't have the sunlight hitting our surface. We don't have the sunlight energy warming the surface, and so we're going to have a cooling effect that's going to occur. And it's not going to go, dramatically down because we have those greenhouse gases naturally occurring with our environment. That's going to allow for the temperature to cool off a little bit, but still keep it within a nice livable range for us. So what happens if we take a look kind of across our solar system? We're scientists, or at least I'm a scientist. I want to look at that and ask some questions. And so, do the equivalent of Fox 29's weekly forecast, but in this case, instead of looking across a week in Philadelphia, we're going to look at the, the average temperature expectation for, the first three planets of our solar system. Mercury, as a little rocky planet with, virtually no atmosphere being present on its surface, is going to be very close to the sun. It's going to get to the point of 800 degrees Fahrenheit, which is really, really hot and probably outside of our livable range for more than, a few seconds. But then, when the sun sets, when Mercury kind of rotates around so that the surface is away from the sun, it's going to drop from about 800 plus 800 degrees down to negative 290. This is really, really cold. And so we got huge, huge, huge temperature fluctuations in Mercury between daylight, when the sunlight is hitting the surface of Mercury and heating the planet, and nighttime, where that region of the planet is in the shade and not getting any solar energy to be heating the surface. Go to the next planet along, we got Mercury, and then we've got Venus. Venus is estimated to be about 867 degrees during the day, and then it's also estimated to be 867 degrees at night. And so we're not seeing that drop-off that's occurring here. So it's a little bit strange. Mercury, hot during the day, cooler during the night. Earth, over here, just take an example like we had on that previous forecast slide. A little bit warmer in the day, a little bit cooler in the night. We got a little bit of temperature fluctuation based on whether or not the sunlight is hitting the surface. So, Mercury and Earth, we see the temperature drop off when the sunlight's not hitting the surface. Something strange is going on in Venus. We're not seeing that temperature drop off occurring. And so if you look at the data that NASA has on Venus, what you discover is that Venus basically has an atmosphere which has very high accumulations of carbon dioxide. This is like the equivalent of global warming kind of at an unbelievable scale. They've got so much carbon dioxide within their atmosphere that is trapping all of that heat that accumulates during the day and not allowing that to get out and radiate out of the atmosphere and then go off into outer space. And so basically what we're seeing is potentially a warning sign that as the levels of carbon dioxide in our environment would potentially increase, we would lose the ability to kind of cool off in the evening, and potentially we would have kind of a greater kind of heating effect, again, because we would not be able to kind of cool the temperature down during nighttime and potentially during seasons as well. And so what we can see then is by looking at the composition of the materials in the atmosphere, the presence of things like carbon dioxide has a very, very dramatic effect. That's one of the biggest differences between Venus and Earth, is the presence, this high concentration of these greenhouse gases at a much higher concentration that you would normally see, trapping the temperature on the planet, contributing to Venus having very, very high temperatures in the morning, in the day, and at night. Okay, so we've got this situation, and I'm kind of going off in a little bit of a different direction now, and talking about a little bit of bulk flow, talking about kind of inputs and outflows. And so we've got, a little scientist, I'm not sure quite why, kind of standing in a little tub. We've got an inflow going in, and we've got an outflow going out. And so basically we have the situation that if the amount that is going into a system is equal to, balances out the amount that's flowing out, we're just basically going to have, like the equivalent of status quo. The level in here is going to stay the same. So our little scientist with her little Erlenmeyer flask is, she's got her feet wet, maybe up to her knees in there. But because the inflow, input and the output are equal, it's going to stay relatively the same. She's going to be in the same position kind of going forward. Now, if we end up with a situation where the input, the amount going in, is much greater than the amount going out, what's going to happen is that level is going to rise. And so if we take a look at that, our poor little scientist over here with her Erlenmeyer flask is barely keeping her nose out of the water. And so we've got this situation that, she needs to start swimming to kind of float up in that situation. And this is, kind of roughly analogous to what we're talking about with carbon dioxide in our atmosphere and the effect that carbon dioxide, as an example of a greenhouse gas, is going to affect our environment. And so, if we have a situation where, we're producing a little bit of greenhouse gas, but we're balancing out, we got plants that are doing photosynthesis and taking carbon dioxide out of the atmosphere and putting it into the plant structures, we've got a balanced situation. We've got something going on relatively normally. We've got, normal temperature fluctuations, but it's within kind of a set normal range that we would expect. If we end up in a situation where we now are producing a lot more carbon dioxide, a lot more of these greenhouse gases, then we are able to pull out of the environment with, our plants doing photosynthesis. We're going to start to see things accumulate. We're going to start to see carbon dioxide accumulate within our environment, and then ultimately kind of raise to the level where that is going to be trapping more and more heat, much like we see on the planet Venus. Now, ultimately, what we want to do is try to correct that problem. And so to correct that problem, we need to reduce that level. So in the previous slide, it was up to her nose. In this point, actually, we've reduced the inflow going in, kind of the same outflow going out. But, basically, when we were working with different concentrations of things within our environment, kind of like the bulk flow of water into the system, we can either decrease the amount of water going in, decrease the amount of carbon dioxide going into our environment, or increase the amount of outflow, the water kind of draining out of the system is the kind of rough example that I'm presenting here, or pull the carbon dioxide out of the atmosphere to bring it back down to a livable amount. And though this is just kind of in the process, we have decreased the amount of amount of water going in is less than the amount that's going out, so that level is gradually going to decrease. And so when we're talking about greenhouse gases like carbon dioxide, what we want to do is avoid the situation where the level has risen dramatically like we would see in Venus, probably reduce our carbon dioxide emissions, reduce the amount of carbon dioxide going into our atmosphere, and ideally pull more of it out so we're not just trapped up this dangerous level. We're actually going to be bringing it back down to a more livable level without the severe weather changes, the climate changes that we're seeing in the environment now. So the topic of today, the concept of carbon offsetting, is an effort of trying to reduce the inputs and increase the outflow of carbon dioxide into our environment. And so what we're looking at is that carbon offsetting is this idea that we can support projects that are going to reduce carbon emissions, to reduce the amount of carbon dioxide that is going to be present within our atmosphere. And so what you're doing with a carbon offset is you're calculating the amount of carbon dioxide that you would be producing in some type of activity, and then supporting another activity that is going to reduce the amount of carbon going into the atmosphere by the amount of what you're doing. And there's actually two carbon offsetting markets involved. The market started, in the 1970s, but it really didn't take off until after the 1997 Kyoto Agreement. A lot of discussions about what we should be doing about carbon dioxide in the environment, discussions of carbon taxes and carbon credits and other things like that. This is kind of along the same basic concept, but we're intentionally trying to reduce carbon emissions in association with specific types of activities. So I said there were going to be two markets. The first market is going to be a voluntary market, and this is for individuals, maybe small companies, with a desire to reduce their emissions, but they're physically impossible to be able to do that, or economically it's not feasible to reduce emissions. So, if you have a company that is manufacturing something, and in the process of manufacturing your product, you are, producing greenhouse gases. You can reduce your emissions up to a point, but you still need the energy to drive. You still need the process to occur in your manufacturing, and so you may not be able to bring it down to zero. And so instead of trying to get it down to zero and not being able to do whatever it is that you're trying to do, you're going to do the best job that you can, and then support other activities, other projects around the world that would offset or reduce their carbon dioxide emissions by the amount that is balanced by the activity that you're trying to do. There's also a compliance market. This is more regulated, and this is what you see with regional, national, and global programs, with the idea that you're limiting the amount of carbon emissions by a country. Now, with this carbon offsetting, again, there have to be standards, and there are certification programs, at least for the voluntary market, to make sure that, if you were supporting an offset, you're putting funds in to support a reduction of carbon dioxide going into the atmosphere, rather than, supporting something that would have occurred whether your money was in it or not. We want to make sure that we're doing what's called additionality, that we are further reducing carbon emissions rather than supporting something that would be already occurring. Ideally, projects are going to be permanent. And so, not something that is going to take the carbon dioxide out of the environment for a short period of time and then allow it to go back in at some point in the future. We want to really reduce this going forward. We want to avoid double counting. And so, there needs to be good accounting to make sure that the same carbon kind of offset isn't sold multiple times, and so that everybody gets the impact that they have, that they desire on the environment. And then the final concept is one of leakage. And so what you want to do with leakage with these carbon offsets is ensure that you're not reducing carbon emissions in one area, but causing more emissions to be released in a different area. And so this would be like protecting a forested region, but in the act of protecting that region, you're causing another area to be cut down. And so we're looking at having a sustainable project that is going to go through and make a substantial removal of carbon dioxide from the environment. And my slides aren't advancing. We can try that. So just an example of one company, TerraPass, is a company that does voluntary carbon offsetting. This is from their website and basically says, and this is a little bit disturbing, the average American produces 16 tons of carbon dioxide per year through the activities that we're doing, through what we're purchasing, through the waste that we're generating if we're not recycling or composting and doing things like that. And so what they've got is a carbon footprint calculator. So you describe what it is that you do. It estimates that what your carbon impact is going to be, and then you have the opportunity to go through and purchase carbon offsets to kind of neutralize your effect on the environment. And so if we take a look at this, what we can see is that there is a wide range of opportunities available in the carbon offset market in terms of volume on what they're able to pull out of the environment, different types of renewable energy, so hydroelectric plants, wind energy, solar energy are very effective at reducing carbon dioxide emissions because they are not burning fossil fuels. A coal burning plant, an oil burning automobile. We're not doing automobile, that's down here in transportation. A oil burning electricity plant, something like that. They're all producing lots and lots of carbon dioxide. And so by reducing the amount of energy that we have to produce by fossil fuel burning, using these renewable energy sources, we're able to remove or at least reduce the amount of carbon dioxide that's being produced and put into the environment to power our lives. Forestry and land use, another common area where we take a look at carbon offsets, reducing carbon emissions, because plants do it naturally. Plants do photosynthesis and pull carbon dioxide out of the atmosphere and store it away. And so having more plants available, ideally larger plants that more fully grown, that are going to be able to take in lots of carbon dioxide annually and then store it within their structures. And I'll just go to the next one, waste disposal. And so if you're not composting, organic waste that goes into landfills produces a lot of methane in the breakdown of that, breakdown of those organic molecules, the food particles. And methane is actually a whole lot worse than carbon dioxide. I think methane is about 20 times more effective at trapping heat than carbon dioxide. And so it's going to be good to reduce carbon dioxide, but it's also going to be good to reduce methane production through organic materials going into the landfills and things like that. And so lots of different opportunities, looking at the electric cars, hopefully using renewable form of energy to get the electricity to drive the cars or power the cars, as opposed to burning gasoline, which is a big emitter of carbon dioxide. And so we can take a look at this. Again, this is the TerraPass website. And you can go through and offset individually 1,000 pounds of carbon dioxide at a time. And when I downloaded this image, it was about $8 per 1,000 pounds. And you can actually get a 50-cent reduction in the cost if you get a monthly subscription. So if you consistently purchase these carbon offsets. And so with that kind of introduction, it gives rise to our ethical dilemmas in science. And I've actually got three options, three ideas that I thought, and I couldn't choose one, so I'm going to include all of them in here. So the first one, should companies be permitted to purchase international carbon offsets instead of making further improvements to their own emissions? And so a good example of this would be a coal burning plant, say in Pennsylvania, where I'm located and where Arcadia University is located. Burning coal produces a lot of carbon dioxide, but it also releases other pollutants as well. And so the incidence of acid rain that occurs in the American Northeast is a result of some of those other pollutants, sulfur getting up into the atmosphere and basically interacting with water and producing acids. And then those acids will come down as acid rain and then affect the environment. They're going to affect individuals, and they're basically be a little bit disruptive. And so if we're taking a look at something like a coal burning electric plant that is producing both carbon dioxide and sulfur gas, we can do carbon offsets. We can do a reduction of that, but that's not going to minimize the amount of carbon dioxide that the plant is producing at that location, offset by a reduction someplace else. But it's not going to reduce the factors that are going up and contributing to acid rain. And so, basically CO2 is a global problem, but other pollutants like sulfur can contribute to local problems downwind. And so this question then can kind of take it a little bit of a step further. Should companies be required to reduce their own emissions to a target point in addition to any purchased carbon offsets? We take a look at this and it's like, oh, well, I'm going to continue business as usual, continue my polluting ways, and I'm going to make myself feel better and get good publicity for the company by purchasing carbon offsets in another location. And in doing so, we've reduced the carbon that is going up into the atmosphere, but could we be reducing it even further if we were to improve both the carbon and other pollutant emissions that may be present there? At a certain point, we want to try to get to a point where we are hopefully not producing, a large amount of carbon dioxide that has the potential to go up into the environment. The second question, second possible ethical dilemma in science, do carbon offsets provide appropriate stewardship of the planet for future generations? If we take a look at this, and this is from one of the carbon offset certifying companies, this is one's gold standard. Taking a look at this, and on the slide, the bars on this, so the solid bars that we take a look at, are the volume in metric tons of carbon dioxide that are pulled out of the atmosphere. And then in the lighter blue is the actual cost of a single metric ton of carbon offsets. And so what we can see is a situation where a lot of efforts in reducing going towards renewable energy, reducing fossil fuel emissions, landfill methane, getting rid of the organic materials going into the landfills and harvesting the methane that's being released, trapping it before it can get into the environment, and potentially using that as a biofuel. But what we can see is that in a situation like this, we've got a lot of variability of the price of a carbon offset for a metric ton of carbon. And so, are we going to be in a situation where people are going to be paying for relatively cheap carbon offsets that are not going to have kind of a lasting and sustainable impact on the environment? How do you ensure that the projects that are funded through this offset program is going to be the best for the environment? Does it matter if we are reducing it in one way or we're reducing it another way. It doesn't matter as long as carbon in our atmosphere is being reduced. And then, a further question, kind of similar to the first one. Should activities that have high levels of carbon emission be specifically targeted for reduction rather than an offset? And so reduce the amount of pollution being generated as opposed to offsetting it potentially someplace else. And then the final ethical dilemma in science option that we have here is, are the benefits and burdens of a carbon offset program shared equitably? If we take a look at this, and this is using data from the Global Carbon Project, the darker colors in this, we can see the United States here is a very dark brown, is an example of a country that has a high level of carbon dioxide emissions per capita. And so per person, we have some of the highest levels of carbon dioxide emissions being released into the environment. Other countries have much, much lower levels of carbon emissions, but potentially, are we limiting their ability to develop their economies by making it harder and harder to go through and release carbon dioxide into the environment? And finally, going back to our public service announcement, we wouldn't leave our dog in a hot car with the windows up. But then should we consider what we're doing with the environment, with these greenhouse gases, and with our own activities that contribute to the emissions of carbon dioxide and other gases that are potentially causing an increase in the temperature of the planet? Again, I'll put some links to the references down below in the comments. And as always, hopefully you enjoyed this. Hopefully the dogs weren't barking too loud in the background. Thank you and have a great week.